Good morning, boys and girls. My name is Mr. Matara, and today we're going to talk about absolute value equations and graphs. Alright, so quick absolute value review. Technically, the absolute value of a number of value is the distance between that number and zero. But what you need to remember is absolute value just is going to make everything positive. Because when you talk about the distance between a number and zero, whenever we talk about the distance is always positive. Okay? So we're going to take the absolute value of a number, it's just always going to make it positive. Alright, when we do absolute value, now like on these first problems here, absolute value like parentheses, you have to do what's inside first. So, 4 minus 8 is negative 4, and so now I'm going to take the absolute value of negative 4. But I've got to do whatever operations are inside first before I try to take the absolute value. The distance now between negative 4 and 0 is 4. Or the absolute value of negative 4 is 4. Again, it's just going to make everything positive. Alright, number 2. Same thing, I'm going to do inside the absolute value first. So negative 6 minus 12 is negative 18. I'm going to get that to one number. And then I'm going to take the absolute value of negative 18, makes it positive, so we get 18. Okay, that easy. I'm going to leave number 3 for you to try yourself, and I'm just going to throw the answer up there later. But you can work on that on your own if you would like. Alright, on number 4 now, again, inside the absolute value, that becomes positive. But that doesn't mean my answer is always going to be positive. If I have a negative in front of the absolute value, that negative is not, again, inside of that stuff. So, like on number 4 here, the absolute value of negative 6 is positive 6, but we have that negative that's already in front. Okay? So my answer ends up being negative 6. If I have a negative in front of absolute value, it doesn't matter, doesn't matter what's going to be inside there, but my answer then would always be negative because the negative is in front of the absolute value. So same thing on the next one here, that negative is going to stay in front of the absolute value. I'm going to do 12 minus 3, which is 9. Again, the absolute value of 9 is 9. It just makes everything positive, but the negative's in front, so then it becomes negative 9. Okay, so if there was no negative, the absolute value of 9 would just be 9. Because the negative in front, I get negative 9. Alright, if you want to try 3 and 6 on your own real fast, go ahead and you can check your answers. You just might want to pause the video. But for number 3, you should get 4, and number 6, you should get negative 3. Alright, let's solve some absolute value equations. Alright, so our first one here is fairly simple. Absolute value of x equals 4. We probably can guess and check this one. We know that if I plug in 4, again, absolute value makes everything positive. So absolute value of 4 is 4. So x equals 4 is one of our solutions. But because absolute value makes everything positive, I also could plug in negative 4. And the absolute value of negative 4 is, again, 4. So, when we solve an absolute value equation, we're going to get two answers. In this case, I get x equals 4, and I get x equals negative 4. Okay? That's why when we solve these things, because we're going to get two answers, we do what I kind of call setting up two cases. Case 1 to find one of those answers, and case 2 to find the other answer. For this problem, it would look something like this. Case 1, case 2. On case 1, what you do is you just drop your absolute value sign. So if I drop my absolute value, I get x equals 4. On case 2, you're going to drop the absolute value sign, but you set this side over here negative. You're saying, what if all that stuff inside the absolute value was equal to a negative? The only thing I got to do before I do this is I always got to make sure that the absolute value is isolated and all by itself, which it was in this case. So that's another way for me to get to my two answers, x equals 4 and x equals negative 4. So when our equations get a little more complicated, like number 8 here, that's exactly what we want to do. 1, you got to make sure that your absolute value is isolated. And then you're going to set up your case 1, case 2. And again, to find what case 1 needs to be, all you're going to do is you're going to drop the absolute value and just write the equation. So in this case, 5x plus 20 is 45. Okay? Just set it up first. Then I'm going to set up case 2. And again, to set up case 2, what you're going to do is, same thing, drop the absolute value, 5x plus 20, but now you're going to set it equal to negative 45. Okay? We're going to say, what if that step on the inside was a negative 45? Then if I were to take the absolute value of it, I would get positive 45. Right? And now you just need to solve these two equations. So in case 1, you would subtract 20 from both sides, and you would end up with 5x equals 25. And then we'd have to divide both sides by 5, and I end up with x equals 5. All right? I'm going to follow the same steps on case 2, but because that number is negative, I'm going to end up with a different answer. Minus 20 from both sides, and now I get 5x equals, but because that was already negative, now I'm going to get negative 65. And when I divide by 5 on both sides, now I'm going to get x equals negative 13. So there are my two answers for this equation, 5 and negative 13. Okay? Always remember to set up case 1 and case 2. Now really I forgot one little piece of this step. Before you set up case 1 and case 2, again, always make sure that the absolute value is isolated, but then you're going to want to take a peek over at the number on this side over here. In this case, the number is negative, right? Negative 15. Well, we just talked about how absolute value is always going to make everything positive. So when would a positive number equal a negative number? It's not, right? That will never ever happen. Okay? So that can't ever happen. It won't ever happen. Those will never be equal. So therefore the answer to this is going to be no solution. And the important thing is, again, you got to be paying attention to this, and you got to check, because I could set up case 1, case 2, and I could go and find two answers. But those two answers are what we call extraneous solutions, because they won't ever work. When I plug them in, I'm always going to get a positive 15, not a negative. And so therefore, my answer has to be no solution. You just have to be paying attention and see this. All right, so we'll do number 10 together, and then I'll let you try number 11 all on your own. So again, first step, make sure you isolate the absolute value. In this case, on the side of the equal sign with the absolute value, I have a plus 6. So my first step has to be to minus 6 from both sides. And when I minus 6 from both sides, we're going to end up with the absolute value of 3x plus 5 equals negative 4. Okay? Then, normally we're thinking I need to set up case 1, case 2. But again, before I set up case 1, case 2, I better be paying attention. If I look here, oh, that is an absolute value equaling a negative number. That can never happen. So my answer again on this one is no solution. Make sure you always look for that first. All right, on your own now, I'm going to say, go ahead again, pause the video, and you can try number 11. So your first step, again, to isolate would you have to add 7 to both sides. You're going to solve for the absolute value just like you would a variable. So I'm going to add 7, and I get negative absolute value of 4x plus 12 equals negative 4x plus 2 equals negative 12. I would say, again, you can't say no solution yet because we're not completely isolated, right? I still need to get rid of that negative 3. So now I'm going to divide both the front and the back by negative 3. And when I do that, I get the absolute value of 4x plus 2 equals 4. And as I'm doing this, you can see my line here a little bit darker because the first one I did was a little small. Be careful of the absolute value that they don't look like 1s and you turn that 4 into a 14. Make sure you can read your own writing. Okay, so because it's an absolute value equals a positive number, I now need to set up case 1, case 2. So that's 4x plus 2 equals 4, and 4x plus 2 equals negative 4. And now I'm going to go and solve for my x's. And when you do that, you should get 4x plus 4x equals 2, and then divided by 4, and I get 4x equals 2/4, or 1/2, when I reduce. Same thing on the other side, I should get x equals negative 6 over 4, which reduces to negative 3/2, negative 3 over 2. So those are my two answers to number 11. All right, now that we know how to solve an absolute value equation, let's talk about how to graph an absolute value function. Okay, to graph an absolute value function, you need to remember that we use HK form, or what's called vertex form, where the h and the k are going to shift the vertex, or the pointy part of the graph. Okay, if you remember these graphs, we'll talk about y in a second. These graphs make a V, and the pointy part of the V is called the vertex, and the h and the k are going to shift the vertex. Okay, we call this shift a translation. Okay, the translation or shift. The h, again, is going to shift the graph left and right, and the k is going to shift the graph up and down. Here's what you have to remember is that the h is always going to shift it opposite of what you would think. It's actually going to shift it left if it's x plus a number. If there's a plus sign there, even though you think positive is to the right. And it's going to shift it right if it's x minus a number. And the reason behind that is because in our equation, it's x minus h. So if h is a positive number, if h equals 2, a positive 2, a shift to the right 2, then my equation would look like x minus 2. So minus is really a shift to the right. And if h was a negative number, like negative 4, then this would become x minus a negative 4, and minus a negative really becomes a plus. So if it's x plus, it's going to shift to the left. If it's x minus, it's a shift to the right. The k is exactly like you think. If the k is positive, you're going to shift your graph up. And if the k is negative, you're going to shift the graph down. Okay? So that's how we shift or translate our graph. It's all based on that hk. Now, let's talk about the a value, the one in front. The a value is our vertical stretch or vertical shrink. Okay? If you think you were to take this v and you were to pull on it, and stretch it, it's going to make the v skinnier. So if the a value is bigger than 1, it's going to be stretched or skinny. And if the a value is smaller than 1, between 0 and 1, a fraction, then it's going to become fat. Okay, the reason this happens is because the a value is like the slope of the sides of our v. Okay, so the a value is the slope, and you'll see how that makes it skinny or fat. And then the other thing the a value will do is if the a value is negative, it will reflect it, or it'll make it open down. And we call that a reflection. Okay, if the a is negative, the v is going to open down. It'll be like a mountain instead of a v. And again, that's because a is the slope. And then I forgot to write this down before when we talk about it, but again, to find the vertex or that pointy part of the graph, that is your hk, and you can just write it as a point, and that's the point we're going to start with to find the vertex. All right, so let's graph one of these. All right, so if I want to graph this, the first thing I have to find is the vertex, and I'm going to find that using my h and k. We said that because this is x plus 4, I know that that is going to shift the graph left 4, or that my h has to be a negative 4. So the x coordinate of the vertex has to be negative 4. The k value has to shift the graph up or down. And so again, because this is a minus 2, I know that this is going to shift the graph down 2. Or the k value of my vertex is negative 2. So the vertex is going to be at negative 4, negative 2, or left 4, down 2. So I would start with that point right there. I know that's going to be the pointy part of the v. Now, I'm going to look at the a value. And in this case, because there is no number in front, when there's no number, I know that my a value has to be 1. And again, the a value is just the slope of the side of the v. So from this vertex point, I'm going to do my slope. I'm going to rise 1, and run 1. And that will give me now one side of my v. Again, I'm going to stop at that vertex point, though I don't want to go the other direction. When I go to do the other side of my v, I need to use the same slope, but I got to go to the left. So now I'm going to go up 1, left 1, up 1, left 1 to create this v pattern. Once I have my dot, then I can go ahead and draw it in and draw my arrows. And this graph would look something like that. All right, let's go ahead and try number 13. All right, so in this case, again, I need to start by finding my vertex, the hk. In this case, there's just an x on the inside, so the h is 0, and my k is negative 5. So that tells me not to go left or right. I'm just going to go down 5 to my vertex. And there's our starting point. Next, I need to find my a, so that I know the slope of the sides. In this case, our a is 2, or 2 over 1, so that's the slope I'm going to use. So I'd go up 2, right 1, up 2, right 1, up 2, right 1, and then I need to follow the same slope on the other side to give me my v. So up 2, left 1 I go. Once done, I can fill in my graph, and you can see how the a value, since it's bigger, made this v a little bit skinnier than the last v, or it's vertically stretched. Okay, let's move on to number 14. So in this case, it's going to shift it right 5 and up 2. So 5, 2. Draw that vertex in, and then find your a value. And a is negative 1 or negative 1 over 1. So now I can draw my sides. In this case, my slope is negative 1 over 1, so down 1, right 1, down 1, right 1. And then I got to go and go the other direction to give me the v. And now you can see how that negative flips my v upside down and really makes it a mountain. And that is what this finished graph should look like. Okay, I'm going to say don't be afraid of the fraction and decimal. I'm going to have you really quickly try to graph these on your own. All right, go ahead and check your answers here and make sure your graphs look like mine. That 0.5, again, is just the same as 1/2. Fractions are friends. I would rewrite it as a fraction, and then I can graph away. Well, boys and girls, I hope you enjoyed this lesson. If you have any questions, please see your teacher, and have a nice day.